The point of the last video was to go through these differentiation rules on this sheet and this sheet. We ended last video with a couple of examples here. I want to do 2 more examples, again using R1, R2, and R3 of t as given here. So the next one is going to be the derivative with respect to t of t to the 4th times R1 of t. So which one does this fall into? This is a scalar function times a vector function. And so this goes into the scalar multiple rule down here. So what do we have? We'll have the derivative of the scalar function times the vector function plus the scalar function times the derivative of the scalar function. So this is going to be the derivative of t to the 4th, of course, is 4t cubed, times the vector function here, t squared, t cubed, and t, plus the scalar function times the derivative of the vector function. T to the 4th times the derivative of this. I wrote it down here after getting it fixed up. So that will be 2t, 3t squared, and 1. If you want to group everything by components, this ends up as 4t cubed times t squared is 4t to the 5th, and there will be plus 2t to the 5th I hat, plus 4t to the 6th, I guess 4t to the 6th, let me get that right, plus 3t to the 6th times j hat, plus 4t to the 4th, plus t to the 4th times k hat, or 6t to the 6th I hat plus 7t to the 6th j hat plus 5t to the 4th k hat. Note that multiplying a scalar function by a vector function gives you a vector function, so the derivative of this vector function should also be a vector function, and we can see that. The last example here, the derivative of R2 of t squared. So this is going to be a chain rule problem. The derivative of u of f of t is f prime of u times u prime of f of t. So here f of t is t squared. So we need to multiply by the derivative of t squared, which is 2t. And then in this case, R2 prime of t is given right here. 3e to the 3t, 2e to the 2t, e to the t. And so what we have to do is that we have to multiply 2t, the derivative f prime of t, with u prime. Well, we found R2 prime of t, but replace t with f of t, replace t with t squared. So that would be 3e to the 3t squared, 2e to the 2t squared, and e to the t squared. And so here is our final answer. I think it's worthwhile to just go through a couple of these examples, because this list of rules can look rather overwhelming at times, and doing these kinds of examples help make sense. Okay, so the second thing I want to do in this video is to prove the dot product rule. Okay, so let's prove the dot product rule. So once again, this is the rule here that we're looking for, the derivative of u of t dot v of t, u prime of t dot v of t plus u of t dot v prime of t. So how do we do this? So let's write out u is equal to u1 I hat plus u2j hat plus u3k hat with, really when we write u1, u1 is a function of t, u2 is a function of t, u3 is a function of t. And ditto for v, we'll write that as v1 I hat plus v2 j hat plus v3 k hat. v1 is really a function of t, etc. So when you want to take the derivative of u dot v, the derivative of u dot v, well, u dot v is u1 v1 plus u2 v2 plus u3 v3. And so when we take the derivative, we're going to use the product rule 3 separate times here. So we would end up with, so again, u1 v1 u2 v2 u3 v3. These are all functions of t. So u1, the derivative of u1 v1 is u1 prime times v1 plus u1 v1 prime. The derivative of u2 times v2 is u2 prime v2 plus u2 v2 prime. And the derivative of u3 times v3 is u3 prime times v3 plus u3 v3 prime. So then take a look here, make it sense of what's going on, and there's a reason I wrote these in 2 rows here. u1 prime v1 plus u2 prime v2 plus u3 prime v3, this is just going to be u1, sorry, there shouldn't be a u1 there, it should just be u prime dot v. Because the components of u prime are u1 prime, u2 prime, u3 prime. The components of v are v1, v2, v3. So take the dot product, you get this. And then this term down here, when you add these together, you'll get u dot v prime of t. So u prime dot v plus u dot v prime. And that proves, you know, I've been dropping the dependence on t there, that's implied, but that gives you this product rule, this dot product rule. And you can prove other rules here similarly.